Hey you, do you want some code?
Welcome back. It's time to talk about the diagram that looks a lot more complicated than it actually is. The JavaScript runtime. As we mentioned before, JavaScript is a single-threaded programming language, meaning it has only one stack and one heap. Therefore, if any other program wants to execute something, it has to wait until the previous program or function is completely executed. And if I do something that takes a really long time, well, things are going to be really slow for our program. That's not good. Boo, that's not nice, is it? We don't like that. And this is where the JavaScript runtime comes in. In this case, the web browser is working in the background while the synchronous JavaScript code is running. And it's using something called the Web API or the Web Browser API to communicate and inform the JavaScript engine. Hey, I'm back with some data and work that you asked me to do in the background. Let's dive deep into this topic. The Web API comes with browsers like Chrome, Microsoft Edge, Safari, and Firefox. Each of them has its own JavaScript engine implementation and a JavaScript runtime that provides a Web API. These Web APIs allow our applications to perform various tasks, such as sending HTTP requests, listening to DOM events, and handling click events on the DOM. We can also use them to delay execution using functions like setTimeout and setInterval. Additionally, they can be used for caching or database storage in the browser. Let me demonstrate what I mean. If we go to the console here and examine the window object, we can see the Web API provided by the browser. As I scroll down, I can see different functionalities that the browser offers for our JavaScript engine to utilize. For example, if I scroll down to the fetch function, there is the function we can use to make HTTP calls. If I keep scrolling down, let's look at something fun like IndexedDB or IndexedDB. There is actually a little database that we can use in our browser. If I go to the application here, I see that I have some storage and IndexedDB that the browser provides for us. That is very cool. If I keep scrolling down, I also see something familiar to us, such as setTimeout. Let's see where is it. Right here. setTimeout, setInterval. All of them are provided by the browser. They are not native to JavaScript. So, remember that the browsers are helping us create rich web applications so that users aren't just sitting around waiting for our JavaScript to execute anything that can be offloaded. They'll take care of that for us in the background because you can imagine if the browser had to use the same JavaScript thread for the execution of these features. Well, it's going to take a really long time. So browsers actually use low-level programming languages like C++ underneath the hood to perform these operations in the background. And these APIs are called Web APIs because, well, there's APIs provided by our web browser. And these Web APIs are what we call synchronous. That means you can instruct these APIs to do something in the background and return data once it's done. Meanwhile, we can just continue working on our JavaScript code stack and execute functions. So, what are these other two things? Now we are only going to scratch the surface here because towards the end of this course, we have an entire asynchronous JavaScript section. But this is what happens underneath the hood. We have items on the call stack, and as soon as something comes up, like set timeout, that's not part of JavaScript. It's part of the web API. The call stack is going to say, oh, I have something that's not for me here. It's for the web browser, for the web API. So it's going to say, hey, web API, here it is. I don't know what to do with this. You take care of it. The web API is going to say, I know what the set timeout is. Let me take care of that and to do that in the background. Now, with the set timeout, you usually want something to happen afterward. So once the web API is done working on it, maybe it's fetching some data from the server, it's going to say, all right, I'm done with this work. Here's the data, and here's perhaps a callback of what I want you to do with the data. And then the event loop is going to say, as soon as the call stack is free, it's going to say, hey, I have something for you here. Would you like to add it onto the stack? And if the stack is empty, it's going to push this callback onto the stack. But that's kind of confusing. Let's actually code this and demonstrate how it works. Imagine we had a console log, and in here we'll just print 1. And by the way, this is really common interview question, so I hope that catches your interest. And let's say we'll also do set timeout, which is part of the web API. And in here, we'll just give it a function, and we'll just say console log 2, and it'll say 1000 milliseconds, or 1.5, and then console log 3. Now, if you've been working with JavaScript for a while, this isn't difficult. You know what's going to happen. But just to go over it quickly, if I go to my browser here, let's copy and paste this and run it. I get 1, 3, 2. Why that? Well, it's because we added console log to our stack and we logged onto our console. Then we removed that call from our call stack and went to the next line, set timeout. We added these to our stack, and then immediately the JavaScript engine is going to say, oh, set timeout, that's a web API. I don't really care about it. I don't know what to do with it. I'm just going to send it off to the web API. So this gets moved away from the call stack and sent to the web API. Now, we don't know what's happening on the side of things, but we just go to the next line and say console log 3. It's going to log 3. Behind the scene, the web API is going to take the set timeout and start the timer. The timer is going to run for 1 second. And once that 1 second is over, it's going to push the callback. The callback is what to do once it's done running for 1 second. In this case, the callback is console log. So it's like it's calling us back saying, hey, we are ready for you. 1 second has passed. Can you console log 2? And what happens now? The console log 2 goes to the callback queue. Let's go to the diagram. It goes to the callback queue and says, I'm the first person that's done. Can you console log the event? The event loop is a loop that constantly runs saying, hey, is the call stack empty? Is the call stack empty? Is the call stack empty? The event loop only runs once, and the call stack is empty, and the entire JavaScript file has been read. In our case, console log 3 will be printed and popped off the call stack. No matter how fast the web API responds and puts console log 2 into the callback queue, the event loop won't start putting anything back into the call stack until the call stack is empty. and we run through the entire file at least once. So in our case, after console log 3 gets printed and popped off the call stack, the event loop is going to tick and say, alright, can you console log 2? And that's why we get this weird pattern. Now, Philip Roberts, who has an amazing talk about the JavaScript event loop and this whole JavaScript runtime system, created this tool to actually visualize this much better than I could explain. We are going to go over the same steps that we just did. We see that we have a function A that calls function B that calls function C, and function C that calls setTimeout. That's a web API, and it's going to have a callback function that once it's done, running for 3 seconds, will call achieved nirvana and console log achiever nirvana. You're enlightened. Let's see what happens, and before I click play, see if you can predict what's going to happen and test yourself. Let's have a look. So we see right away that A gets called. That's a very first thing that happens because up until now we just declared functions and we only run on line 17. We execute function A, so function A gets executed and we call B. So we add that to the call stack and then we resume calling C, which gets added to the call stack and then C gets called. That is, we add setTimeout to the call stack. And what do you think happens here? Well, setTimeout now gets sent to the web API because, well, it's a web API. And we don't really care that the web API does with this. It has its own implementation. But in this case, it's using this timer to run for just 3 seconds, so that it can add to the callback queue. But in the meantime, our JavaScript engine doesn't care what's happening. It's just going to keep working on the stack. So if I resume here, you'll see that A, B, and C all get popped off the stack while the timer is running. Now let's see what happens when this timer ends. I'm going to resume and look at that. It finishes in 3 seconds. So it's going to put it back or put it into the callback queue. And the callback queue is going to say to the event loop, hey, can I come back to the stack? I'm lonely. Can I come back to the stack? And the event loop says, hold on. Let me check. Is the call stack empty? Yes, it is. Has the entire file been run? Yes. Well, line 17 is the last line. So that's the last thing that we want to run. Oh, see, you're allowed to go back on the stack. So I'm going to resume and look at that. The achieved nirvana is going to get popped or pushed onto the stack. Console log gets printed, and then we pop everything off the stack. Woohoo! Congratulations! We just achieved nirvana. That's not too bad, is it? Now, here is a fun little question for you. What happens if we do the exact same thing, but this time at 0 here? What do you think will happen? Well, if I run this, I get 1, 3, 2, still. Now, like I said before, this is a very common interview question. The reason that happens is that no matter how fast the setTimeout timer happens, it still gets sent to the web API, still gets sent to the callback queue and the event loop. It still needs to check those two conditions. Hey, is the stack empty? And has the entire file been run? In our case, no. We're still waiting for console log to run. And only then will I push our callback function, our console log, to our call stack. How cool is that? And using this method, we are able to have the power of asynchronous code that instead of being limited to one call stack and one memory heap, allows us to handle tasks that can be asynchronous and take a long time, such as modifying the DOM or making HTTP requests. In that case, we can just send those tasks off to the browser. The browser can run them in the background. And whenever we are ready, it can use its callback queue and event loop to notify us. Alright, that was a long one. Let's take a quick break and I'll see you in the next video. Bye bye.